Got a problem with the forks on my 1937 Scott, and we need to fix them before we can get the front wheel on, because I can't ride a unicycle. So I've got some new parts and we need to do a bit of fettling and adjusting on them before they'll go on, and then hopefully we can get it all back together and on the road. Hello and welcome to Tweed's Garage, where in this video we're in the conservatoire, as I like to call it, with my 1937 Scott. Yes, it's been allowed in the house, well, nearly in the house. Mrs Tweed has sort of softened a little bit and allowed me to bring it in here so I can sort of show it easier to you guys out there, and also so it's easier for me to work on and try and get it up and running. As you can see at the moment, it's a unicycle. It's only got one wheel. No front wheel, no front forks. They're all missing. Why is that? Well, there's a problem. They're oleomatic forks, so they're not sprung with springs like regular forks. They're actually cushioned with air, so they're reliant on air staying in them all the time, because if not, when the air goes, the forks collapse down to the ground, and then you've got no suspension, so you can't ride the bike. So I've got the old fork tubes here, as you see. There's a fork tube here, looks fine on the outside, but on the inside, with years of wear, it's got sort of scoring on the inside. They're normally highly polished, and the trouble is the scoring allows the air to escape over a short period, and they gradually go down. You have to keep pumping them up, which is a bit of a chore really. It shouldn't lose any air at all when they're in good order. And then another problem with these is because they're very thin tubing all the way down, and because of the age of the bike, the amount of miles it's done, they do actually have a slight curve to them where they've been, hammering down the road all these years. So what I've got is a new set of tubes to go on, which I have down here, like Blue Peter. Here's some I prepared earlier. Yes, no, you're not having the cardboard tube, because I need it. In there, try and keep me finger grease off of them if I can. And there you go, there's the new ones. Hopefully, I was hoping there'd be a straight swap to put on, but we have a couple of issues, and I'll go through those with you down the workshop. Yes, we'll feed you in a minute. So here we have some of the items getting ready to sort some problems out and get the forks back together. We've got, as you've seen already, the old fork tube and slider. The other one's down the house, but looks exactly the same. And then we've got the fork inners. These bolt into the headstock and sit downwards, and the tubes and the sliders go over the top. And then these hold all the seals to keep your air in. And also there's fork oil down the bottom as well to act as a bit of damping. So you've got seals down there to keep the oil in the forks as well. And then the way you get the air in on this one, there's normally a tyre type valve on here that you access through this slot on the forks. Here you put a cycle pump on it, and you can pump air into the forks or lower them down depending on your load, how many people you've got on the bike, that kind of thing. And the way you tell that, there is a there's a witness mark there. So if it's just yourself on the bike, just pump air in until that witness mark appears, I think in this hole, if I'm correct. If not, just below there, but I think it's this hole that it should sort of pop into, and that's your sort of ride height that you set it to. And this is why you want the air to stay in. You don't want it going back down again as soon as you've taken the pump off. And what happens then is there was a copper tube brazed in that goes from this one across to this one, sits in the bottom of the headstock there like that. Yes, that just sits in there like so. But unfortunately, over the years, where people undo the nuts at the top, or the securing bolts at the top, you shouldn't really undo them. All the forks you normally strip from down below and leave these in position. But the tube had fractured, so I had to take it off. Did attempt to try and start silver soldering it up, but it was starting to damage the surface that's plated on here. These are made by Dowty, so this is sort of what you get on avionic equipment. I'm not sure what sort of plating it is, but they're definitely steel, he says. Magnet, not very magnetic steel, but there's definitely some magnetism to them. So I didn't want to go any further and destroy all this, so yeah, corrosion would set in. We've got a little bit there, but we can clean that off and yeah, put a bit of preservative on that to keep that. So I've come up with a new solution that allows you to strip the forks down, and then there's no chance of damaging a hard fixed tube between the two. So we're going modern pneumatic tubing, this sort of nylon tubing here, and then we've got these pneumatic push fit fittings, 8mm thread. So the first job I need to do is drill and tap those holes for 8mm, so I can put these unions in there, and a bit of Loctite or PTFE tape to make sure they're sealed up. But I also have to be careful they don't come into the inside of this bore here, because they'll foul up with the bolt and seal that goes down the top. So yeah, they might need trimming back a little bit as well. They're only stainless steel, so we can nip them back a bit, so that when they're done all the way up, there's no interference fit between this and the securing bolt that goes down there. So that's one job to do. So we're over at the mill. I worked out how to clamp the job in a mill. It's just a V-block clamped to the table and squared up. I mean, it doesn't matter too much because we're centering on this hole. But anyway, it makes it easier. So squared the block up, clamped it down, and then the valve assembly sits in the V-block with the stirrup clamp, clamping it down, bit of brass just to stop it damaging the surface of the valve assembly. And then with a drill blank that fits the hole that I drilled to clear out the copper tubing originally, just done by hand this one. Got a drill blank that fits down through that hole like that. Use that to line the mill up centrally with that hole. Zeroed my digital readout, and then went in on each side with a wobbler to get the true central position of this diameter here. Then pop the drill blank back in again, and with it now set to 0 in the middle of this true, went in with the drill blank, bored it down, and then just moved the assembly until the drill blank dropped down through it, and I knew it sort of spot in the middle. And then we've got a 7mm tapping drill we run through, and then followed that up with got a set of taps here, 8mm metric fine, 8mm by 1mm pitch. But I only needed to run the taper tap through this one, not all the way, just ran it down through, so the top of the thread here is close enough to the finished size, but there's a bit of meat further down because this is actually a tapered thread on here. So yeah, as it winds in into a tapered hole, it seals up. So yeah, we don't want it full 8mm thread all the way through. And then what I'll do is that fits in there quite nicely, goes a few threads down and then starts tightening up. What I'll do is then do them by hand to get this to go down a little bit further, but not too far that it pops out, and that will seal that up quite nicely, but with a bit of Loctite as well. That's that one done, and I'll just run you through the process of doing the other one. Yeah, here we go. And there we go. And then I'll just finish fitting them by hand. That's that job done. Okay, so that's the top part of the forks sorted out with those valves in, so they can be finished off, ready to go back into the top yoke when it goes back on the bike. That's all sorted. Now the next thing I need to do is put the new tubes into the fork lower yoke. Now there's a sort of little bit of a problem. The new forks have been made to size 1 7/8 of an inch in diameter. Yeah, there's a little bit of difference between two, but there's a thou difference between the two. But unfortunately, although that's the spec, these holes are a lot smaller. And the way they've done the original forks is they soldered these brass bands on in position where they sit in the lower yokes, and they get clamped up on this brass piece here. Now this one, you see, it's sort of coming unsoldered, which made them a bit tight to get out. But I suspect they could solder these on, and this being brass, it's easy to, you know, with a bit of emery cloth to bring it down to size if the tolerances are a little way out. But now we're dealing with, you know, modern CNC machine stuff with old hand turned up stuff, and we're coming across problems. So this is the way Stoyan has redesigned these. So there's a step here. This is the thicker part. This is representing this band here, this diameter here, but then this goes all the way down to the bottom of the fork, so you get this heavier gauge tubing down here to add a bit of strength to the lower tube. What I was going to do, the easy thing to do, I thought, would just be to bore these holes out to a tight fit for the new tubes. So it took a long time measuring them. So the way I measured it is bore gauges, which what these are. They're sprung loaded like that, and then you can twist the end and lock them into position. And then there's a little bit of give against the brake as well. When you lock them off, they can squeeze down and still stay in position. So what you do is you release the clamp, drop them in the bore you want to measure, just roll one end down lower than the other, lock it off, and then just with your fingers just flip it out, roll it out, and then that should sort of push that down to the size of the bore. And if it stays where it is, then you can just pop it in your micrometer and measure off your distance and make a note of it. But it's a bit, you know, it's a bit hit and miss. And so what I'd done was took 6 or 7 measurements, and then you average them out, you know, to give you a reading as accurately as you can. And then I forgot, I've got sort of internal bore gauges, these ones, these little Mr Tweed ones, that do a slightly better job. They are a fiddle to use. Same sort of principle, you drop them in like that. I've set this one so it will just roll at the highest point. You can move it from one end from side to side, so you know it's in the middle in the high spot. See, so it'll swing from one side to the other because they've got rounded ends, and then you go in the middle of that and then roll it backwards and forwards until it rolls out without catching. And then to get your measurement, you either go by your lowest measurement there on the little tubes that you put on to make it wider, so 37 plus the 6 spacer gives us 43, so that's our zero position is 43, 44, 45, 46, 47.35. And then I just saw, no, I've got my maths correct. I just dropped that in the micrometer there just to confirm we're there. And the same with the in the bore, you just sweep it on its little rounded anvils, and you can just feel it just touching the other side of the micrometer. Yeah, 47.350. So they're a little bit more accurate than that, but they are a fiddle to use because you have to sort of set them and then drop them in and keep bringing them out and keep, you know, adjusting it until you get that slight bit of friction, but not, you know, you're not having to force it, you can just feel it just touching. Confirmed it with that. What we found is, yeah, this side is smaller than that side, but then there was two things against machining. The first thing here, there's only sort of 3.4 millimeters here of meat on the brass, slightly thicker on this side, but unfortunately this is the side that needs more material taking out of it, so didn't really want to do that anyway. But also it's made more complicated because there is a rake angle built into these forks. So what is rake angle? Well, it's sort of like the angle when you look at motorcycle, like the Excelsior over here, you know, the forks don't go down 90 degrees, they're raked out at an angle at the headstock like that. But then also sometimes more on custom bikes, choppers, that kind of thing, they put rake on the fork set as well, on the clamps. So you'll notice when I drop this down, you'd think, you know, if there was no rake angle, these holes would be centered to these holes, but you can see there. See if I can get it on camera. Let's turn it the other way, see if it picks it up. Right, if I line that up about there, I'll move it back as forward so you can see they're set back. So with these set back up here and those set forwards, it means your forks stick out at an angle, and that's your rake angle. So there's a little diagram there. So this is the fork spindle there going through, and then this is the upper clamp, lower clamp, this is back set, so the forks run at an angle, and this is your angle compared to your stem, and that's your rake angle there. Now it's put on some bikes to make them more stable in a straight line. This used to be done a lot on choppers where they had ridiculously long forks. They had to increase the rake, sometimes not being able to do it by chopping the frame and moving the headstock. So what they had was fork sets like this that have a rake angle built into them to make them more stable. Disadvantages, especially on choppers where they got really kicked out forks and an extreme rake angle, it makes the wheel want to drop from side to side when you're riding really slowly, and it can build up into quite a dangerous wobble, you know, which you can see with some choppers when they sort of head off. You know, they start their front wheels sort of flopping about and then they wrestle it into a straight line and off they go. So I suspect, I may be wrong, but my bike's a 1937 Scott, and that left the factory with girder forks. And then after the war, a new frame come along and they were fitted with these oleomatics. And then Scott also offered the oleomatics like an upgrade set for pre-war bikes. And I suspect the headstock angle on a girder fork frame is different to a bike that has telescopic forks on. So the way they've got round that is to build in a rake angle in the fork clamp set to correct that. That's my theory anyway. So you might find maybe Panthers after the war, some of the after war Scots, they might not have this rake angle in them. They might just be straight down. Anyway, so that just made it, what I'm saying is, because of this rake angle, these holes, when you're looking down, you know, if you bolt this stem in the mill as your sort of datum point, these holes aren't parallel with this. You know, they go in at an angle like that. So one, you need to know that angle, or you've got to find it. You've got to find the centre points, you've got to clamp it. And as you see, it's a casting, and I suspect when they were machined, they went on a jig, and it probably didn't have the stem in, or the, you know, the base plate for the steering damper. So really trying to machine that, and with the very little material on there, I decided that I needed to do the machining on the new forks. Yeah, I know, didn't really want to, but that's what we're going to do. So we've got to take off on the larger size, I've gone for the larger one first, just in case make a mistake, and then we can always turn it down to the smaller size. Need to take off 0.311 of a millimetre, which is sort of 12 thou, which is not a lot. It's like that, you know, thick bit of paper. So I might just be able to do it with emery cloth. I'm going to see how I go. But what I'd done was got a piece of steel out the scrap bin and just kept machining it down to this, 47.342. And then that is a nice fit in there, and it's a pretty tight fit. The other thing is there's going to be paint on the forks as well. I mean, I need a little bit of give in there to hopefully get it through without taking all the paint off. You know, there's bound to be some come off, but if I spray it thinly, I might get away with it. But yeah, as you see, that's a reasonable fit. What I also done was, when it was a tight fit, I just popped some Brasso on this, and at a very slow speed on the lathe, just lapped this hole in with this and a bit of Brasso. So it just cleaned up some of the lips. It's not a perfectly round circle. Now, what I've discovered is, to aid assembly disassembly, you've got these slots in. I mean, they're really clamping slots. But in the manual, I say put a screwdriver in there and bang it in to open up the clamp to make it easier to get the fork tubes out. But what I've discovered is, if you bang a screwdriver in there, it sort of moves it away there, but it tightens up here. So it just, it doesn't really do anything. It just ruins your paint on your forks. But that's a nice fit in there, and then just nip that up. Now, let's get a spanner, pinch that down, and that is now in there, nice and secure. That's perfect. That's all it needs to be, because you've got the top of the forks up here, and they're bolted down as well, so they're not going to go anywhere. And then your fork tubes come up and slide over the valving and seal rods that go down here, and they sit on the shoulder there. So once they're in here, you know, even if this was loose, they won't go anywhere. There's nowhere for them to go. That's where we are at the moment. We've got the first one sorted out for size, and I've just got to machine the fork tube down to size to be a nice fit like that. And then we haven't sacrificed any material out of here. And then what I'll do is pop this back in the lathe, take this down so it's a snug fit in this side. Same thing, lap it in with Brasso, measure it, then that'll give me my measurement to take the second fork tube down to. Right, we're back on the bench. After you watched me machining the second tube, I'd already done the first one. So the first thing to do was machine down my gauge so that it was a nice sliding fit in this side of the yoke, which it was. And once I was happy with that and sliding this on, it was all a good fit. I zeroed my reading on my turning tool, so I knew that was my finished size, and then popped this tube in as you saw and clocked it in as good as I could get it by moving it around. It's not too critical because, you know, they clamp on here, there's nothing spinning around, they're fixed. So yeah, just got them as good as I could get them, and then proceeded to turn down this sliding face where it clamps into the yokes. And as you see, that went really well. Test fitted the yokes afterwards, that was good. Clamped it up, they clamp up. So we'll just sort of assemble them on the bench so we can have a look at them fully assembled. Now they will have paint on in a little while, which will make life a bit difficult. That's why I ran Scotch-Brite over this nice machine surface. It's just to give a bit of a key for when we paint them. And then I'll use my adjustable just to annoy people. Right. So, yeah, and it doesn't take a lot to clamp them up nice and tight, which is just what we want. And there's that one as well. And there we go. Forks now go together, so we can get these back on the bike once I've painted them. So making progress. Anyway, better put them back in the tubes until I can get around to painting them. So far it's all been going really well. Got these push fit valves in the top of the fork tube assembly, and I think with a bit of Loctite and done up, they're going to be nice and airtight, keep the air in. And we've got all the new seals to go on when we reassemble the forks, and machine that 0.3 of a millimetre off of these new fork tubes without ruining them, and they assemble really nicely now and clamp up nice and tight. But as with all old vehicles and motorcycles, there's always a curveball thrown at you when you're least expecting it. So yes, that's why these aren't on the bike and won't be in this video. This is as far as we're going to get, because we have another problem, which is when I took these apart, they were sort of bent in towards the top and pushed in. That what made them really tight and tightened it all up. But when I look at it now with the new tubes in, and those new tubes are sitting pretty parallel, I mean, I will measure them, but they look pretty good, and the eye's pretty good at telling these sort of things. They do run, yeah, pretty dead parallel actually. So that suggests to me that these holes are good. But when I look at the top yoke, you know, I can get this one that nearly over the top of the tube, and then this one, you know, I can get my finger in. You know, it's sort of about 4 or 5 millimeters back. So, you know, if you split the difference and move it over there, this tube you'd have to push this way, and there's not really enough give in this brass casting to allow you to spring that in. I think this is why the old forks had these brass bands on. They're soldered on, and I just think it gives a little bit more give, a little bit more movement when you're trying to, you know, line the tubes up. But I've had a look over it, and I've sort of spotted that the stem is not sort of parallel to the tubes. If I look from here, you can see it goes that way, and it's hard to tell this way because, as I said to you before, there's a slight bit of rake angle on there, so this won't run parallel, this stem won't run parallel with these tubes. But there's definitely, when you look here, this stem goes that way, sits that way. And if I could get it to sit in the middle, I think that would move this yoke over the top of this one. Yeah, and it would, and it'd move it over that way, and it would all line up. So I think my issue is with this stem. Not sure whether that is pushed in. I think I'm going to have to bite the bullet and try and press that out and have a look whether it's the hole that's bored at an angle, not quite right, so it might need sleeving, you know, press sleeve in there and then reboard so that it's straight, or whether the stem is bent. It doesn't look bent, it just looks like it goes through at an angle. You know, it might just need a tap, I don't know. Anyway, that is a problem for another video. So there you go, that'll do for now. We're not rolling, but we're heading towards getting it back on its wheels. So hope you liked the video. If you did, give us a little like, hit subscribe, and we'll see you in another video. All right, cheerio. All right, Jenkins. Yeah, I'm going back down the conservatory. It's warmer down there. What are they?
Forks.
Forks. We're in the conservatoire, as I like to call it, with the 1930... Oh, I've got fluff on my hand. And then these are the new ones to go on. Turns back to the audience to annoy the wife. Pigeon! These are old bits and they're worn out, but I need to fix them. So I went by hook.